Okay, thank you guys for coming out. Hey, hey, Mike. We've got built-in hecklers. Thank you. So my name is Keith Basil. I work for Red Hat. I'm on the OpenStack product management team, and I cover security. Let me start my timer. So for those who were with us last time, I'm not gonna, sorry, let me calm down here, my coffee's kicking in. We did a complete roadmap thing at Sydney. We walked through compliance as code. So really this presentation is kind of a update from where we are. We are about to release OpenStack version 13, and I'm going to highlight some of the major security features that come with 13. So we'll take questions afterwards. So this will be pretty quick, maybe 30 minutes, 35 minutes tops, and then we'll have 5 to 10 minutes of questions, and you guys can go on to your next session. So with that, we'll get started. So a little bit about me. I'm big into off-road dirt biking, building the car. The picture in the middle is my Photoshop vision for the end result. So it's been a couple of years as my friends joke me about it, but it's in progress. I used to work for cloud scaling. Any Randy Bias fans in the house? Time Warner Cable and some federal-related cloud infrastructure work. And you can find me by my moniker, No Sleep, NOSLZZP, pretty much anywhere. So I took the role for the product management of OpenStack Platform security about 1.5 years ago. And what was happening at the time was we were getting inundated with a lot of requests for, what's our response to this? How do we cover that? Are we going to do this, X, Y, and Z? And not only was it like the standard security questions, but it was the standard security questions on a global scale. So we'll get into that a little bit. So I quickly realized that we needed to look at the risk management frameworks where OpenStack was being deployed. So this is just a list of logos for various risk management frameworks. So you'll see the big circle on your left there is ANSI. That is a French government organization. And then the US ones you'll notice like FedRAMP and DISA and NIST, right? So we had to have security answers for our product related to these frameworks. So that was contributing to the chaos at the time when I took the role. And not only that, but we had to look at compliance up and down the entire stack. So some of these frameworks even have levels of compliance, like you can go low, moderate, and high. And for those that went high, they want to have things like attestation of the hardware exposed to your stack, right? So that was a whole separate set of controls that we had to have answers for as product folks. So lots of frameworks, complex stack, and then you combine that with the 6-month cadence of OpenStack, and you have a recipe for legitimate nightmare, okay? And we'll talk about how we resolve that a little bit later, but just to dive a little bit deeper before we get to the strategic parts, I'm kind of setting this context up so you can see where we're going. Not all risk management frameworks, sorry, let me rephrase that. As Red Hat, as a software company, and as OpenStack as software, we cannot address all of the control groups that you will find in a standard risk management framework. So this is what I call the FedRAMP cheat sheet, meaning that the things that are encircled here are things that we as a software company care about. So access control, audit and accountability, identification and authentication. Those are things that we have influence on that we can affect, right? Things that we don't have influence on is like physical security. Like, do you have guys with machine guns at the data center, right? That's not Red Hat problem, right? But depending on that level of compliance, your customer or the OpenStack deployer may need to answer those questions to check the boxes for this given framework. Okay, so back to my job, my day job. So all of this crazy madness was going on. I said, okay, what's our way forward here? So what I did was I looked at the Cloud Security Alliance control groups. The reason I did that is because they have a really cool tool called the Cloud Controls Matrix. And it's like the Rosetta Stone for compliance, meaning that if you address like EKM here, like the 1, 2, 3, 4, 5th one down, where it says encryption and key management, right? If you answer one of the controls there, you can then use their tool, the spreadsheet, to see, okay, this maps to ISO, this maps to PCI DSS, this maps to FedRAMP, et cetera. So it was like the Rosetta Stone for compliance framework. So we internally at Red Hat are sort of standardizing on this top layer of controls so that when a question comes in, we can triage it, and you'll see a little bit of that later, to say, okay, how does this apply to OpenStack? This is the answer, and this also applies to the other 15 frameworks. So it makes our job a little bit easier. It gives us a map, if you will, a structure to actually handle security, as well as tell a story that's specific to a given control. And that's probably the most important thing as a product manager. Okay, so with all that context, this is the Red Hat strategy for security for OpenStack. Okay, so let's talk about this. It's compliance driven, just for this very reason I gave a little bit earlier, because that gives us, number one, it lets us to address globally these compliance frameworks. So now when I go to Paris and I'm having meetings with, let's say, a telecom company there, they ask us about security, I ask them, okay, what compliance framework are you beholden to? And they'll say, oh, ANSI has to give us an authorization before we can deploy OpenStack. And then I'll say, okay, great, these are the answers that we have for ANSI. So the story is very easy to tell, okay? You can go to Australia, same thing. Figure out what the compliance framework is for Australia. You go to the US public sector, same thing. Is it gonna be FedRAMP? FedRAMP is the cloud service provider framework that you must adhere to before you can even sell into the public sector, okay? So we did that, so that's great. So the compliance-driven approach is there. The second thing we did is we looked at the Cloud Security Alliance's matrix, and we noticed a pattern. If you solve for, let's say, the gold standards of frameworks, you kind of get everybody else by default, right? So the most difficult one that we've seen, the one that we have most experience with as Red Hat, is the FedRAMP high. Actually, FedRAMP moderate and high is the most prolific for us, right? So when we solve for that, we kind of automatically, due to that mapping, we automatically get like checkboxes in all these other frameworks. So within that group, we focused on these four you see at the bottom here, which is the technical control groups. They're infrastructure and virtualization security. So everything related to OpenStack that we can dump into that bucket, we do. Encryption and key management, so we'll be talking about Barbican. Identity and access management, Keystone and backend plugins and things like that. Threat and vulnerability management, okay? So we get a lot of that from the past performance and artifacts from Red Hat Enterprise Linux, okay? And then again, just to raise our focus a little bit more, we focus on FedRAMP as the gold standard. Because again, if we can solve for that, we get 90% of everybody else. And then ETSI and ANSI are NFV telco-specific frameworks. Because we see a lot of rise, and you notice in the agenda, you'll see a lot of edge use cases, telco use cases. So they have very specific and different security requirements, especially around like what they call lawful intercept, right? So the ability to do tracking and tapping of mobile services through this OpenStack-based infrastructure, right? So we have to make sure that those boxes can be checked. So that's our focus. By doing FedRAMP, we get a lot of people. We get the financial services, we get healthcare, all of that, because we start at the most stringent federal level, and we come down from there. And then we have this telco-specific focus as well. So that's the focus. Okay, so that's the context. Let's talk about the actual roadmap. So I know for those that the first time that have seen this is a bit of an eye chart, but it will actually make sense in about 2 minutes, okay? This is what we call internally at Red Hat the Thai flute roadmap, okay? And going from left to right represents time. So as a product manager, one of the things that I struggled with when I first got to Red Hat was going from classical product management to product management in the open source world with a project that moves very fast, with engineers that kind of want to do their own thing, right? So what we've done is we've kind of consolidated the new approach, let's call it that, with this roadmap. So going from left to right represents time. The bars in the security sense represents those control groups that we talked about earlier. And going from white to darker blue represents maturity. Because of the OpenStack cadence, we treat feature development as an epic that will go across multiple releases. And so each bar represents the maturity of the features within an epic being developed, okay? So if you look at the bottom, you see 12, 13, 14. These represent, corresponding to Pike, Queens, and Rocky releases of OpenStack. So, and there you have it. So in 12, we did TLS coverage for pretty much all of our services. We introduced this thing called NovaJoin, which I'll talk about and walk through a flow. And we introduced the OpenStack Security Guide. So just briefly on the Security Guide, I was one of the co-authors of the first OpenStack Security Guide upstream. I think that was summer of 2013, where we all got in a room together and 6 days later, we cranked out a book, which is pretty cool. That effort was great as an OpenStack project. It was wonderful. But the problem for us as Red Hat is that it was more philosophical as opposed to being practical. Okay, because we didn't want to bring all these Rail-specific configurations to the book when people can pick their own distro and operating system. We wanted to be neutral in that regard. But our customers were not very happy because they wanted to get a book and says, okay, this is what you do this, do this, do this, but it wasn't there. We did not have the specificity for Rail in the security guide. So what we've decided to do as Red Hat is we did a downstream version of that that's very specific to the stack that we sell. So that's the first version of that. And then we started renaming it to match the release of the product. So we're going to spend most time here on 13, a little bit of vision toward 14. So with 13, we finally have released Barbican with OSP 13. So Barbican is basically secrets as a service. And that unblocks quite a few of user stories that we had around security, encrypted volume support, signing, and Swift object encryption as well. So continuous infrastructure and vert hardening. The guide has been updated. It's really nice right now. And we can talk about 14 in a second. Okay? Actually, I'll talk about it now because we won't spend too much time on this. I'll skip the HSM part because I'll talk about that in a second. But we're going to have intrusion detection via the AID project as part of OSP 14, configuration file secrets, and then we're introducing what we call compliance as code, and I'll speak to that toward the end of the presentation for a few minutes. We're looking at IPsec support. As you know, and you'll see later, that the services and communications of the control plane within OpenStack is very complex. To meet some security requirements, people want to just not so much drop TLS, but have IPsec underneath everything to guarantee that we have coverage there. And then we're working with Intel and some others, particularly in the US public sector. There's some strong demand there for what we call trusted compute, where we can do attestation of the hardware and extend that compartmentalization of the processes to VMs as well as containers. So that's really exciting work by some of our friends in the public sector. Okay, so let's jump into this. So we're going to talk about NovaJoin. NovaJoin was released in OSP 12, but we didn't really cover it too much last time, so I'm just going to run through that real quick. What NovaJoin is, it's a service that interacts with the metadata service when we deploy OpenStack. This is not tenant-facing, so number one, I want to caveat that. This is for the ops person to enroll the Overcloud nodes. Actually, I probably shouldn't use the word Overcloud because that denotes understanding of OOO in Director. So when you deploy a compute node or controller, this is the service that NovaJoin registers the controller and the compute nodes with our deployer tool called Director so that you can manage the certificates on the service. So it's probably better to show you that in terms of a flow. So the undercloud here is our Director. That's the deployment tool. And we have Yarda Kofal in the audience, who's the product manager for Director. So if you have any questions, you can ping him later on this. But the undercloud deploys the Overcloud. And once that's done, the node is registered, gets a one-time password. That gets sent to the metadata service on the Overcloud node. It phones home, and then it gets proper certs for the Overcloud. And what this does for us, let me go back, is that now any service that runs on the Overcloud node, like Keystone, Barbican, Horizon, that needs a security certificate, it can automatically get one from the IDM server without any manual configuration. Okay, so it has saved a tremendous amount of time in terms of deploying certs. It also does revocation and renewals automatically, and it will bounce and restart the services once those new certificates are in. So it really makes it kind of zero-touch configuration for security certs for all the control plane services within OpenStack. So it's a really powerful service. Okay. What that does, though, it introduces our IDM service, which is a separate product which is included in the OpenStack platform. There's no additional thing you'd have to buy in terms of a subscription. But you can do cool things like centralized Kerberos, sudo policies for all your ops guys. So it's really powerful in that regard. The NovaJoin kind of certificate management piece is just one part of the capability and value chain that IDM provides. Okay, so moving on. I'm going to talk about the internal TLS work. So before OpenStack Platform 12, we only had the edge of the cloud secured, and now we were pushing to do all the internal services. So that is being ongoing. So we all know how complex OpenStack is, and so some of these services have been really challenging to lock down, but we're making progress over time. What also complicated it from Red Hat's perspective is that we went from, let's say, OSP 10, OSP 11, which were non-containerized control plane services, which we did have full TLS coverage for, to containerized services. So we had to basically refactor all of the TLS enablement work between versions, which is why we didn't release Barbican a release back, because we just didn't have the agile velocity to do that. We had to drop something, and Barbican was the victim in that case. But we did move over to the containerized deployment, all of the TLS work. If you guys want to copy this, just hit me up later and I'll send you this. But this is basically a chart of the ongoing enhancements with TLS coverage for internal services. So we've pretty much got everything except for services that are in progress or planned. So like Ironic and Overcloud is planned later. Open Daylight, I think will actually make OSP 13. And then Ceph is pretty complex with the authentication and the OSD traffic and such. So that's a work in progress by the Ceph team, okay? Okay, so let's talk about Barbican. Secrets as a service. So Barbican can store and retrieve, generate symmetrical and asymmetrical keys. So think of it as keys as a service or secrets as a service, but in a multi-tenant environment, right? So the keys are kind of bound or compartmentalized by either the user level or the project level, okay? And there's several backends that are supported by Barbican. So the one that we're supporting out of the box with OSP 13's release is the simple crypto backend, which is the database backend. The keys are wrapped with a master key encryption key, a master KEK, and then they're stored into the database, and they're reverse process coming out. There's also PKCS11 protocol support. PKCS11 is a protocol that used between services and things like an HSM, a hardware security module. And that support is there, but we don't have a certified is a little bit strong, but we don't have a fully tested back end yet. We do have a few HSMs in the lab that have just been delivered, and we intend to have HSM support for at least minimum the Talus box as a point update for OSP 13. The other thing about OSP 13 that's important related to this is that it's a long life release for us. So any of the HSM support that's going to come later, it will pretty much work on OSP 13. So it's safe for folks in here, especially in the telco space, to standardize on Barbican and OSP 13 as a long life release. So the use cases that it unblocks, the number one that we're seeing is the encrypted volume support. We'll walk through an actual flow of that so you can see how that works with Barbican, encrypted objects and signed images. Okay, so let's walk through this. There's a preliminary step here that's not shown, and that's where the ops folks, the people who are deploying OpenStack, need to set up the encrypted volume type so that it is available to the tenants. So this assumes that that type of volume is available by the person on the left, the tenant. So the tenant then pulls down and says, hey, I want to create an encrypted volume. Sender requests the key from Barbican. Barbican generates the key, wraps it, stores it in a database, as we described, based on whatever backend is there. The reference to the key is returned as metadata, okay, and is attached to that volume. And so when Nova goes to attach the volume to the instance, it pulls the metadata back from sender, uses that as a reference lookup to Barbican, and Barbican requests the key, checks the credentials, obviously, make sure that that ask is appropriate, and then retrieves the key, unwraps the key, and sends that key to Nova. The actual encryption method at the Nova level is with LUX. Okay, so the LUX volume is the type that you'll set up for the volumes there. So the keys pass to LUX, and LUX does its thing, and you have an encrypted volume. Okay, last thing is the IPsec coverage. Again, it's very low level. There's some services that are really tricky to get done right in terms of security with the TLS. There may be use cases where that level of complexity is not needed, so IPsec will be a future option for encrypting the communication. So this is what we're dealing with OpenStack. So imagine managing certificates for all of this. And this is essentially our problem. This is why we're making the IPsec option available in the future. And so we've done some preliminary work with this. We have an Ansible role today. This is not supported, by the way. It works, but it does firewall configuration for the node that it's deployed on. It's only done with a pre-shared key at the moment. So later, we might explore having certificate management for all the tunnels and such as well. So it's very basic, but it does work. We're going to obviously integrate this into Director. Right now, it's a post-deploy configuration to enable IPsec. And again, it's not supported, but it will be supported in the future. We're also we're also exploring various NIC providers who have IPsec offload to help with this in environments that require high performance. All right, so those are the broad features that you'll see as part of OSP 13. So looking toward the future, going back to this compliance-driven approach, I'm going to talk about compliance as code for maybe four minutes or so, and then we can take questions. Okay? All right, so here's essentially the problem that I described earlier. So on the left there, you have basically OpenStack, right? So you've got all this configuration, and on the right, you've got all the compliance framework. So let's just use one of those, for example, and this is a real-world example. And I did this a few years ago myself from paper to actually what they call an ATO, an authority to operate. But our customers who are using OpenStack in the public sector, in the federal space, they have to create a document. The document template that's empty is like 400 pages, okay? So when you have to basically answer questions that the government's going to review on how you address personnel security, encryption and key management, et cetera, et cetera, et cetera. And you fill out this document. It's called a system security plan, all right? And normally it takes, I think the average is 2,600 hours to create this document. So you can do the math from there. The problem is once you say, okay, I'm going to create a SSP, a system security plan for OpenStack version 13, it's going to take you 2 months to do it, right? Then you submit the document, and it's going to take another 4 months for the government to review that. It's called a joint authorization board, and they assigned, I don't want to get into the detail, it's complicated, but there's what's called a third-party assessor that looks at your document, look at your system, and then the joint authorization board actually approves all of that based on the findings. And then they give you what's called an ATO, an authority to operate, okay? And that's the magic. Once you get an ATO, you can sell to any federal agency at that level of security. It's totally the magic. It's worth going through it because you can make money at that point. Okay. Create the SSP, 2 months. Submit the documentation, remediate, go through the 3PL, get an authorization. You're looking at 4 months, maybe. And these are optimistic, great numbers. Okay. The problem with that is, as soon as you get an ATO for OpenStack 13, the next version of OpenStack is out. Okay. So you're always on this rat wheel of this hamster wheel, rather. I don't think people have rats for pets, but you're on a hamster wheel of trying to keep up with the compliance, okay? So, and you have to create all these artifacts every time. So if you make a change on a new version, you have to go through an SSP, make the updates, you have to do the audit remediation and the documentation, the whole thing. So it's total insanity, right? So we want to solve this problem. So how do we do that? So you guys remember the control list, right? So what we've done at Red Hat is we've tried to treat responding and creating these artifacts as software, okay? So like the documentation, we have these things called narratives. Like how do you do password management? And there's a narrative, right? This is how we do it for OpenStack version 13, and here are the controls, et cetera. So that's wonderful. We drop that into a format of JSON specific to this compliance as code project that we're working on. So we have that crystallized. And then for bugs and feature requests coming in, we internally have a new triage process that we're testing where the RFE comes in, we assign it to a control group, one of the rainbow groups there, right? And say, okay, this is encryption and key management. Oh, and okay, this will apply to FedRAMP high, moderate, or low. We classify it that way. Then our engineers actually go and do the work. And as part of the new definition of done in Agile, right, they actually ship a snippet of code that's in that JSON format to the compliance as code repo, right, for that version. So it's always in step with our development process. So With low, as a product manager, what I want to do is I want to say anything that's low should be in the product by default. And my definition of in the product by default is if you enable this security feature, it does not break any OpenStack service. Okay, so we should just get that by default, right? So I want to eventually ship what's called an Openstack profile that shows all the security that we've done, all the tweaks, and you can run a test against that to show you red light, green light to say, okay, after post-deployment, right? It says, okay, these are the things that have been checked and you're good, green, 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 right? Or if there's something that you missed, it will show as red against a given compliance framework. So I want to ship that. I want to ship documentation specific to that version as well. And then for our more extreme customers that want to go moderate or high, there's going to be a separate environments directory with all the configuration templates and such for those levels of compliance. And these things are things that if you turn on will typically break OpenStack or require additional thinking in terms of architecture. So for example, if you wanted to do secure bare metal to tenant with ironic and attestation, right, with the TPM, this is where that would fall because you have to build Nova filters, Nova scheduling, you have to set up the attestation server, you have to deploy that somewhere. And so when a customer says, hey, give me a secure machine, a bare metal box, right? Maybe it's a nuclear physicist that's doing research, right? That person has to be able to see that in Horizon, get that, deploy it, and then you have to make sure that the box has not been tampered with, et cetera. So that would be something that would fall under these categories. So we've made some early changes in Bugzilla. So if you go file a Bugzilla under the OpenStack product, you'll see two new fields. One is compliance level, which you see at the top, where you can pick low, moderate, or high. And then if you do know the compliance group, you can actually select where you think that feature would be. And we'll see it on the backside on the product team. And if you don't select that, that's fine as well. We'll still see it, and we can kind of triage that as we go through the process, because our guys are going to see it anyway. And then our next step is to link this with the actual CI system so that we have the security baked into the process going forward. So my goal is to have the CI linkage in place by OSP 14 so that when you get the new version, you also get all these additional security artifacts with the product by default out of the box. So this is what we have here, and this is the power of compliance as code. It's called inherited agility. So what we've done is we've broken out the different layers, right? So on the left there, you'll see layers like the operating system compliance data, the definition, like for example, is this FedRAMP, is this ISO, is this PCI DSS, is this ANSI? So you have the definition, right? And then you have the IS, basically the cloud platform, which would be OpenStack. So you have all the controls specific to configuring and defining the narratives for your system security plan for OpenStack. And then you might want to do a pound include, if you will, for the actual data center that you're in. So for example, we have some federal customers in the Equinix data center in Ashburn. They have controls that they can contribute. So you can just basically pull those in, run the tooling, and guess what happens? You run this tooling, it will automatically generate your system security plan. If you go back and look at the OpenStack Summit, OpenStack Sydney demo, myself and Sean Wells were on stage. We actually did this live. We actually made changes to the Open Control JSON work, reran the tool on his laptop on stage, and we had the change in the output of a Word document that represented the FedRAMP SSP. It was really cool. It damn near killed his laptop, but it worked. So those are the things we want to deliver. So back to the product management focus, I want to deliver a system security plan for every version of OpenStack that we release going forward. I want to give the Openstack profile that shows remediation and testing, because not only do we want to create the documentation, with OSP, let's say 14, I want you to have an Ansible playbook that will fix and check your system. And that's part of this compliance as code as well, is the actual code to do the check as well as the code to do the remediation. And that's where the real power comes into play here. And then documentation, I see Derek's in the audience. Derek's leading the work on the security guide. And I want to hand to Derek. Derek, here are the new features that we developed, and here's the narrative that describes those. Put those in the OSP 14 book as an example. So those are the things we want to do. And again, that's automated, and we want to have this process here, this middle process, this loop here, as part of our CI process going forward, so that security is 100% baked into the product going forward. So that's all I have. If you guys have any questions, feel free to walk to the mic, and happy to take questions.
Aloha, Walt Barnes, AT&T Chief Security Office. Your compliance is code. Why didn't you drive it like into heat so that your infrastructure as code could be combined with your security or compliance as code? And then how do you ensure immutability after you expand it and install it?
Why didn't we? So that's a great question. So we looked at heat. We looked at how to trigger the remediations or the configuration. And we had heat as an option. We had Ansible as an option. We had baked into the images before we even do a deployment as an option in terms of immutability. And then we also had post-configuration options as well. Right now, we're leaning toward Ansible-driven post-config, as well as on the development side, doing it in the image before we ship it. But also shipping the OpenStack profile that matches that version so you can trust but verify, okay? So the idea is to say, okay, here are the images, we fixed these 20 things this release, right? We have remediation checks for every single one of those baked into the image. So when you deploy, they should be there out of the box, right? But you can use third-party tooling like OpenStack Workbench, drop in that OpenStack profile, and then run that against your system to verify that those things are there. So the immutability is, it's kind of there in that secondary example, but the post-configuration deployment is a little bit, shaky. So we still have some work to do on that, and working with you guys, we'd love to have you participate in the upstream community. In fact, Sean and I are actually building some of the community frameworks for that right now. So we're going to make an announcement on that shortly. But I know some of your security guys, and I will send that out to you guys to solicit your input.
And then the follow-up is 1600 Type 4 or a Porsche Flat 6?
Oh, yes. No, they're totally different. It is a Flat 6, same Porsche firing as a 6, 330 horsepower Subaru H6.
Good.
Yeah. So the car went from 30 horsepower stock to 330 horsepower with the Subaru reverse transaxle. The reverse ring and pinion transaxle. Yes, thank you. And a limited slip differential. Any other questions about anything? This is crazy.
Mike Gallagher with Verizon.
Okay.
In your opinion, SC Linux, what role does that play in compliance, and how important is it?
I think it's very important. SC Linux to me falls under the infrastructure invert hardening, and we have enabled that. And yes, that's where it is. It's there. We should have it.
Which compliance, all of them?
The better question is, what control group does that fall under? And to me, it lives under infrastructure and virtualization security. And it answers a lot of controls that you'll see specified in that group. And then we can take the mapping of, let's say, the Cloud Security Alliance group and see where it fits to ISO, FedRAMP, et cetera. So it's going to apply to a lot of things is the answer at the end of the day. But its home, to me, is in infrastructure and vert security. Yes, sir?
So if I can add something about the Linux.
Yes.
Because I'm an engineer working on KVM. So
Okay. Do you want to go to the mic so it can be recorded?
Yeah. Especially if you're using KVM as the backend for OpenStack, which is the case for Red Hat OpenStack, the whole security of libvirt, which Nova uses to start virtual machines, is based on SE Linux. And it's what really guarantees the isolation between the QEMU processes. So it's, I wouldn't consider a KVM deployment secure if it doesn't use SE Linux.
Yes, agreed. Thank you. Yes, sir.
Sam Bawari, Verizon. You talked a little bit about AID in version 14.
Yes, it's going to be tech preview in 13, so you can actually get the code and test it out, but not support it in 14.
Can you talk a little bit about the capabilities and features and such?
Yeah, sure. For any of the old heads in security, you know what Tripwire is, right? Okay, so it's like the latest version of Tripwire, but automatically deployed by a director. You can set up cron jobs for reporting if there's drift or any kind of diff for the file integrity checking for the deployment.
Is that in the Overcloud or?
It's not for the tenants, it's for the ops layer, it's for the Overcloud nodes, the compute nodes, the controller nodes, et cetera. Is that Dan?
Yeah.
Dan.
So one of the day two operations that a lot of operators face is, now that I've got OpenStack deployed, how do my firewalls above OpenStack need to be configured? Are you doing anything to move that out of documentation and into infrastructure as code, publishing a JSON or anything like that?
That's a great question. I don't have an answer for you at the ops layer, but we were talking to Intel about a project called Open Security Controller, which basically was an automated way to do east-west traffic within a tenant plane for compartmentalization based on the firewalling rules and such. We punted on that for the short term because there was overlap with the ONAP work from the NFV space. So I don't know where that's going to go, but I think it's needed, and I'd love to talk to you about it.
Yeah, I'm doing some work to automate those firewall implementation
Okay.
features, but it would be great to get that automatically out of each new version of OpenStack, or even as you make changes in choosing which services you're deploying.
Yes.
What are the actual ports needed?
Where do you see that work landing? Which project area? Which is it just?
I don't know.
Okay.
That's why I'm saying,
Okay.
in the structure that you're publishing the SCAP data,
Yep.
there might be something in there where it would be appropriate to publish, that same kind of data.
No, that's a great point. Let's talk about that later. The second thing too is that, how many here know what Skydive is, the project Skydive? Okay. So Skydive is kind of like a visualization of the network flows for the entire the underlying infrastructure. We're actually thinking about using output from Skydive to help influence and do ports and protocol mapping in this system security plan as well. So I think that might go hand in hand with the work you're doing going forward. So we should definitely talk about that because that will be a game changer for infrastructure.
Great, thanks.
Yep. Any other questions? It's a scary thing. Any other questions? Cool. All right, I appreciate your time. Thank you very much.